Hello friends, this video on Communication Systems Part 15 is brought to you by examfear.com. No more fear from exam. So let us start our discussion on amplitude modulation. We will mathematically see what changes take place in the carrier wave. So how amplitude modulation take place? So let us see how amplitude modulation takes place. So now we will see the mathematical aspect of it, right? So what all do we need for amplitude modulation? We need a carrier wave. Let us suppose we are considering here a sinusoidal carrier wave. So how do we denote a sinusoidal carrier wave? So the signal is denoted as C of t, which is a function of t that is varying with time. That is equal to AC, that is amplitude of a carrier wave is denoted as AC, sine omega c t, where omega c is the angular frequency of the carrier wave. We also need a modulating wave or the message signal wave, whatever you call it, because the message signal wave is the one which actually modulates the carrier wave. That is why it is also known as modulating wave. So this is denoted as m of t, which is equal to am sine omega m t, where am is the amplitude of the modulating wave and omega m is the angular frequency of the modulating wave. Now what happens in amplitude modulation? This modulating wave will combine with this carrier wave. Combine in the sense the amplitude of the carrier wave will get modified as per the modulating wave, right? So what would be the modulated wave? After modulation, what would be the wave? It will be Cm of t. That is the same carrier wave which is modulated due to this message signal. So this will be equal to, what will happen? What will change in the carrier wave? Only the amplitude part will change. The remaining part will remain the same. So let us keep the remaining part same. What will happen to the amplitude part? The amplitude part will change as per this wave. So the amplitude will become AC plus AM sine omega m t. Right? Because if you look at an amplitude modulated wave, so we see this is how the amplitude varies. So this was AC. So the AC, with AC there is some AM plus sine omega t. So this is how we can denote a modulated wave. So let us see what do we get after calculations. So we see AC, if we take AC common, so we get 1 plus AM by AC sine omega m t sine omega c t. So this is equal to AC sine omega c t plus AC into AM by AC sine omega m t into sine omega c t. So this is what we get. Now here we have a ratio AM by AC. So here we will introduce a new term called modulation index. What is modulation index? It is the ratio of the amplitude of the message signal to the amplitude of the carrier wave. So this ratio is known as modulation index. Basically, this ratio tells us how much of modulation will actually take place. Because in amplitude modulation happens on the amplitude. So how much modulation will occur will depend upon the amplitude of the carrier wave and the amplitude of the modulating wave. So this is the modulation index. So it is denoted by mu. So we can replace this AM by AC with mu. So we can say Cm of t is equal to AC sine omega c into t plus mu AC sine omega m t sine omega c t. So we have it in the form sine A sine B. So in trigonometry, we are aware of this formula. Sine A sine B is equal to half cos A minus B minus cos A plus B. I'm sure you would have learned all these things in your trigonometry in mathematics. Therefore, using the same formula here, what do we get? This is equal to AC sine omega c into t plus mu AC half cos omega m t minus omega c t minus half cos omega m t plus omega c t. So this becomes equal to AC sine omega c t plus mu AC by 2 cos omega m minus omega c into t minus mu AC by 2 cos omega m plus omega c into t. So this is the final expression which we obtain for amplitude modulated wave. So what information do we get from this expression? So from this we can see that the amplitude modulated wave consists of carrier wave of frequency omega c. So we have a carrier wave. We see it is a combination of a carrier wave of frequency omega c. It also consists of two sinusoidal waves, each with frequency little less and a little greater than omega c. Right? So if I try to plot it graphically, so how do we denote it? So this omega c is the frequency of carrier wave. So this is the frequency of carrier wave. If you look at this one, this is known as the lower side frequency. And if you look at this one, this is known as upper side frequency. So if you look at this wave is a combination of three waves. One is the carrier wave, which was the original wave. The other one is a lower side frequency where the frequency is little lesser than the carrier wave. And the third is the upper side frequency where the frequency is little more than the carrier wave. So if I try to plot the amplitude with respect to the angular frequency. So what do we see? If we take amplitude on the y-axis and carrier and angular frequency on the x-axis, what do we see? It consists of one omega c, some waves of frequency omega c, some waves of frequency little more than omega c, that is omega c plus omega m, and some waves with frequency little less than omega c, that is omega c minus omega m. Right? Now what is the amplitude of the wave with frequency omega c? They have an amplitude AC. So this frequency corresponds to AC. But the other two waves have same frequency, that is mu AC by 2. So this is the frequency for the other two waves. So that means these two will have the same frequency, and that frequency would correspond to mu AC by 2. Right? So what do we infer from this discussion? We infer that during amplitude modulation, the carrier waves amplitude gets modulated as per the message signal or the modulating wave. So the expression for the modulated wave consists of a frequency which is equal to the carrier frequency, some frequencies little greater than the carrier frequency, and some frequency little lesser than the carrier frequency. So now if you compare this with the graph, what do we see? This is how the graph goes, right, for an amplitude modulated wave. So let us suppose if this was the amplitude of the carrier wave. So how was this modulation done? It happened somewhat like this, right? So that means the amplitude at certain places were little more than the carrier wave. Again, at certain places it was little less than the carrier wave. right? Okay. So this was the mathematical aspect of amplitude modulation. So what we can say is that as long as the side bands, now these are known as the side bands. The second term and the third term represents the side bands. As long as these side bands do not overlap, different stations can operate without interfering with each other. In your radio, you would have seen FM, AM, all those stuffs. So why do you have different frequencies? For example, you would have seen 94.3 FM, 98.3 FM. So why are you able to hear those different frequencies FM so distinctly? That's because the side bands do not overlap. Right? An amplitude, an AM wave will have many different frequencies. Now, if you set each value to each frequency, the side frequencies are not going to overlap. So there will be no mixing of signals and you will be able to hear each station distinctly. So let us look at the graph once again. So this is how the graph looks like. Here we have the frequency. For the carrier wave, here we have omega c plus omega m, and here we have omega c minus omega m. So this corresponds to the amplitude of carrier wave and this corresponds to mu AC by 2. So here we have amplitude and here we have angular frequency. So these two side bands should never overlap. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.